if you draw a major axis and you bisect it, okay? Actually, let me just demonstrate it very quickly for you guys. Okay. That is a 30-degree ellipse. How do I know it is a 30-degree ellipse? I know, and I'm going to show you. And I want you to memorize this, because this one fact you can use as kind of a gateway to a whole bunch of useful information. Here's the fact. A 30-degree ellipse is half as tall as it is wide. So the minor axis if the minor axis equals 1x, I'm sorry, if the major axis equals 1x, the minor axis equals half of that. Okay? Now this is a big deal, but this is the beginning. This is the one I want you to memorize. 30 degrees equals half. Because if you can memorize that, it opens up everything else. Watch this. How can I draw a 30-degree ellipse? Let's say I'm looking down at 30 degrees and I want to make sure it is a 30-degree ellipse. This is how I can do it. I take the width. I split it in half to find the location of the major axis, or the minor axis. But then watch, everybody eyes up for this one thing real quick. So I need to make this half as tall as it is wide. What's the easiest and most correct way I can guess this without pulling out dividers and all that? I go like this, watch. Go from the center of the ellipse to halfway and envision a 45-degree angle above and below. All that 45-degree angle does is it transfers. When you have a 45-degree angle, it means you have a triangle with two equal legs, basically. So all I'm doing is I'm taking a horizontal measurement and making it vertical. All right? Now I'm going halfway because I need half above and half below. It's the right answer. You know, if you do that, that will teach you how to draw a correct 30-degree ellipse. Now it gets cooler. And this is what's on the left-hand side of that sheet. Let's say you want to draw a 20-degree ellipse. You start off the same way. Okay, eyes up. You start off the same way, but now, instead of going halfway, you go a third of the way and draw a 45-degree angle above and below. Now why? Why a third of the way? Because, and this is the key thing, notice, wait, everyone eyes up. 30 is half. 20 is roughly a third the height. It's like 0.34. It's within a percentage point of being a third of the height. And frankly, if anyone knows you're not exact, well, they're a bigger nerd than us. Okay. Now, what'd you say? But John, I had my heart set on a 15-degree ellipse. Anyone want to take a guess? So you do it like this. Watch. Eyes up. Cut it in half. Cut it in half again. Now, I want to emphasize something for your notes so you don't come back to me in 20 years and say, John, I found a mistake. Okay, these are not exact. If you get into the percentages, it's like 0.34, 0.27, you know, but they're so close no one will ever know. You know, if you were doing it in Adobe Illustrator, okay, put in 0.27. And that'll be a 15-degree ellipse. You know, but, you know, no one's going to know. And if you're sketching, this is huge. All right. Now, let's go a little further. All right, 10-degree ellipse. Now, how do I do this one? Eyes up for a sec. I usually do this. I do it just like I did the 15-degree, where I go to the 0.25, and then I usually just take off a fifth more, you know, just a tiny, tiny bit more. And you'll see at this point, we're getting into some pretty tiny ellipses. And then the last one, and this one's the one that screws up the pattern. So we've got, look at this, we've got 2, 3, 4, 5, okay? And this one screws up the pattern. It's 1/10. So what you can kind of do, if you have to draw a 5-degree ellipse, the actual answer looks something like this. But what you can do is just draw the skinniest damn ellipse you can draw and tell someone it's a 5-degree ellipse. I mean, because, you know, come on. Oh, no, that's 7 degrees. You know, good luck. All right, now there are some additional ones. For instance, a 45-degree ellipse. You might say, well, wait, John, you talked about 30, but what's a 45? This one you would not guess, but here's the answer. So how does this one look? It looks shockingly fat compared to the others. You're almost thinking, well, wait, that's almost a circle. You're right, it is. Okay, so you guys, if this is the thing, and here's the halfway point, I go half again before I draw the 45. And you get something like this. So that's a 45-degree ellipse, roughly. Now, there are other degrees as well. You can get into 60 degrees, 70 degrees, but they get so close to being a circle very quickly. Like I think the 60-degree one is like this, you know, and they get it's the inverse of what happens with these skinny ones. They get so close to being a circle that, you know, you don't really draw them very often. You usually just put them, you know, slightly adjusted circle. Yes.
So, if I'm guessing correctly, the degrees are measuring the right the right end of the ellipse?
Oh, the degrees are measuring this. I'm glad you brought that up because I would have forgotten to say this. And I said it to the morning class last week and I forgot to say it to you guys in the other class. Here's what the degree means. If you've got a viewer, if here's your viewer looking out on a scene, it is basically the degree of tilt or